Okay, I know I've covered this before, but it is kind of oblique. When you declare your object, you're not really declaring an object, you're declaring a reference to an object. If you've done C++ programming, you're declaring a pointer to an object. It will eventually point to an object, but it doesn't until you do new car. Once you do new car, it comes out into memory, something called a heap in C programming terms. Don't know how many other people use that terminology anymore. Comes out here, allocates enough RAM for the object to hold the object. And this is saying that there's a car object and it allocated at the memory for at this particular address in your RAM, and then that gets stored in the variable. Now this area is called a stack, and this area is called a heap. Not that you need to know those terms. They're just two different parts of, in the end, in the giant RAM. But Java is managing this as being separate than that.
Are you recording?
I hope so. I meant to be. Yes. Yes, I am. Awesome. Thank you. Thank you. You earned brownie points. So here we created new car. If we didn't have this part, if we just said new car, it'd go ahead and allocate this, but we wouldn't have a pointer to it. We wouldn't have a reference to it. And eventually Java would notice that and delete it because nothing is pointing to it. You absolutely cannot use it, right? It's like you build a house out in the woods and you don't know where it is. You can't go sleep in it. So you have to store the reference, and everybody knows that, but maybe you understand why now. Because until it writes the memory address of that object into the reference variable, into the pointer, it doesn't know where it is. If anything ever stops this from pointing to that, like if you reuse this variable to make another car, like if step 4 was car is equal to new car, Java would come, grab another block of memory, create a new car, it would point to that block of memory, and then this one is now an orphan block of memory. There's no pointers with it, pointing to it anymore. That's orphan memory. The garbage cleaner, again, will come along and fix it, clean it up. In some languages, they do not behave so nicely. You have to free that memory yourself before the object pointer goes away. If you did that, you did car is equal to new car, and then you did step 4, car is equal to new car in C++, it's quite likely that you would wind up with a memory leak, especially if it was in a loop, because there is no garbage detector, no garbage collection process to fix that. As they continue to improve C++ over the years, each new standard comes out, every 7 years or whatever, there's now something called smart pointers, which tries to fix it, to try to make C++ more like Java. So, when you pass this car variable to a method, what it is really receiving is that pointer. Really? Please allow me to put this on mute. Shut the phone up. All right. Where was I going? When you pass this car variable to a method, to a function, right, what's really getting passed is this pointer. That pointer is used to make changes to it. So if it says car.years equal to 2014, it goes ahead and writes it because that function, that method has a pointer to it. But if you change this value, if that function sets car equal to a different block of memory, then by the time it gets back out here, it will not have changed that. Just like any other variable. Java is a pass-by-copy, a pass-by-value language, not a pass-by-reference value. Same is true of Python. Same is true of C++ and C#, except those two languages have two other ways of passing data in. You can pass by pointer, or you can pass by reference. Well, we don't have the option of passing by pointer and passing by reference. If you need the ability for methods to actually modify not the members of an object that is being declared, but to create and to replace objects, then you probably are going to want to make this a member of the class, right? Because once you make something a member of a class, every method in that class can access it. If you wanted to, you could come in and you could set 2 car references equal to the same block of memory. Now we have car, and then we would have another one that looked exactly the same, except called car2. Oh, and you just go ahead and spin your wheel forever. Yeah, whatever. Go away. All right. So anyways, pretend it said car 2, pretend it said 1080, 1062. We would just have 2 blocks to the same chunk, right? Which is fine. Rarely do you want to do that, but it's fine. You may be thinking that this is copying this object into this object and that you now have 2 cars, or that it has made a copy of the original car. And so that you could change the year of the second one and it would keep this one's year the same. But no, they're pointing to the same thing. They're both pointing to the same block of memory. So if you do car 2 dot year is equal to 2018, buy a newer car, it's going to come out here and it's going to change that. It's going to replace that so both car and car 2's year reference will both say 2018. Usually this all works seamlessly. Usually you don't really care much about this. Java is so nice about garbage collection and keeping track of the references and stuff like that that it's usually not a problem. With list when, that can become a problem. Be careful not to reuse the same object when adding to an array. Why? Suppose I create an object, 01. I add it to an array. So now I have an array, right? Element 0 has now got object 1, a reference to object 1, really. Then I want to create a new car, right? But I forget I need to create a new car. Instead, I reuse it. So later on, I don't make a new object. Okay, create an object and then set its data to something, right? And then I add that to the array. So effectively, his data is pointing to something that says 1, 2, 3. And then I feel like adding something else to an array or an array list, any kind of data structure like that, any kind of abstract data type. But I forget to make a new object, so I reuse it. I say, okay, now our data is 4, 5, 6. Add that to the array. Well, now we have another one. It's still got the same memory address. It's pointing to data that says 4, 5, 6, and so does this. Probably not what we wanted. That doesn't happen with primitive data types. You don't have to worry when you're creating an array and it's full of ints or floats or doubles or whatever, about that kind of duplication effect where if you change the data, it's going to change, every member of it. You do have to be careful if you're creating an array of object references. When you copy something into an array, it might be a good idea to copy the object. Why? Because what if I added it to an array and I thought that data was fixed and safe? And then later on, I decided, oh, well, object 01 needs to be set to, something else, 7, 8, 9. It is going to wind up changing this guy's data because it's the same reference. If I had made a copy of the object before I assigned it into an array, then, and only then, is that guy safe from future change. And we haven't been demonstrating that, well, especially since we haven't had a class over. But if we create an array of references and we're copying things into it, we probably ought to be placing things into it. If they are objects, we ought to be copying the objects as we stick them in there. Again, usually we get away with it because we usually don't reuse references, right? But our programs are pretty simple, right? What if we're creating references and we're putting references in 2 different arrays, right? Then when the first array is processed, great. When the second array is processed, if it changes any of those values, it goes back and magically changes the values in the first array as well. So just something to keep in the back of your mind, that as we add things to a data structure, think to yourself, is this something that I should be making a copy of? Here they show an example of inside the car class creating some code that'll make a clone of the object so that you can do something to the effect of, if you had this code sitting there, these notes are not going to make a lick of sense. I may delete those lines. If you have that class, then when your driver for the class could do this, car C1 equals new car, and then whatever. Say that we have getters and setters, right? So C1 dot set year to 1988. It's an old car. Then you want to make a copy of that object in order to stick it in an array. You could do this. Car C2 is equal to C1 dot make copy. And then you could stick that into an array, right? Array subscript 0 is equal to C2. Now that's safe. The original data is completely separate now from this one. So what does the make copy method do? It allocates a brand new car, and then it copies each member into the new object and returns a new reference. Not a bad thing to do. Professor Thompson's recommended rules, make copy ought to be one of those rules. I ought to tack that on there, right? My rules are going to be like 20 items long. And do you have to do all those rules every time? Of course not. They're just things to keep in mind. Copies of this open? Yeah, I do. So to compare two objects, equal is not enough. I've mentioned that before. If you do this, if you had this code, even though they should be exactly the same, they should contain the same data. If we do this, if C1 equals C2, then print out they're the same, right? Print same. They're not the same. Why? Because they have different references. This is at memory address 2000, whatever. This is at memory address, 2010. Who knows? We have no idea what memory address it's pointing to, right? And so this is just comparing those addresses. It's not comparing the contents. That's why you make a dot equals method that compares every item individually. Public Boolean equals, and you take another object of the same type, right? Car other. And then you check them line by line. If, this dot make equals other dot make, actually I'm going to make it not equals, then return false because they're not the same. And I'm going to repeat that a couple more times. If this dot year not equal to other dot year, return false. And then lastly, if this dot color not equal to other dot color, return false. Since string is not an int, since it's not a primitive, since it's an object itself, this would not be adequate. We'll go back and fix that in a minute. But if we can't prove that they're not equal, then finally we can say, okay, it's equal. They're equal. And at the very top, you should have a if this equals other, right? Find out if they are the exact same object. If they are the exact same object, which is what that comparison actually is the only thing it checks, then you want to return true. Why? Because you can save time then. What if you were going to compare 17 or 700 different member variables? You don't want it to have to do that if it can rule it out with one check at the very beginning. Okay, so we've created a dot equals method for our car object. So down here, I should not do that. I should instead do this. If C1 dot equals C2. Always do that if you're comparing strings. Just as a matter of course, you have two string variables, always use dot equals. every object has a dot equals method built in, but usually it just does this comparison. But whoever wrote the string class added the rest of this to make it work correctly. So technically this would be an override. There would be an @override symbol up at the top. Not that that's necessary. It helps debugging though, because it gives a compilation error if this does not match what it is supposed to match. In other words, if it does not match the method signature of the method it is replacing.
Question?
Uh-huh.
I'm puzzling over the if this equal other versus the if C1 equals C2. And you said C1 equals C2 is 2 addresses.
Right.
But this equal other is not 2 addresses?
In this particular case, it would be two addresses. But if we had done this, good question. If we had done this, car C3 equals C1. Now we have two variables with the same pointer. And so if we did if C3 equals C1, then when we got in here, this and the other have the same value. And we'd want to kick them out because they're pointing to the same block memory.
Oh, okay.
Yeah.
But they're pointing to the same block and the contents has got to be.
Right, exactly. So we're ruling out that case. So, Prof's guidelines for class creation. Ditto for everything else we've said. Also, add a make copy or copy of or whatever you want to call it. Or you could call it clone method, so that you can easily copy, so that you can easily make a copy of an object. I said there was still a glitch because this is a string, and what did I say you have to do when you're comparing two strings? This would not work. Well, this wasn't correct either. What did we do to fix it? I know somebody knows, and then I've got to blur it out. Come on, guys. How did we fix this? What did we do? Give me a long night. Come on. Look to the left. Right? We use dot equals. So, yeah, so we would do if this color dot equals other color, and then you could rewrite, you could word it two ways. You could say if equals false because they're not equal, or you could do not, right, like that. Either way, you like saying equals false, it's certainly clear. Sometimes I write it that way. You know, the cool hipster programmers would use the not, right, to be more succinct. We may as well add that on. When comparing strings, always use dot equals to compare them. If you are ever possessed of the urge to do what's known as call chaining, johncar.setMake, .setYear, .setColor, .setMiley, so that you could set all those things at once, you could do that. You just have to make your setters return the this reference, like this. Say I have a rectangle class, class rect. It's got two members, int height and width, and so I make setters for them. Normally I make setters void because they don't need to return anything, right? So I do void set h, and it accepts an h. And in its code I do this dot h equals h, like that. And then I do the same thing for set width, so I'm just going to copy and paste because I'm lazy. And I want to go as fast as possible so y'all get behind. I am kidding. Here we go. There. That's how we have been writing our getters and setters. But if you like call chaining, you have to do this instead. Return this, which means you better not do void. You better say rect, like that. It's not that it's creating a new rectangle. It's that it's returning to this pointer. And why do you want to do that? Just so that you can do this. Rect r1 equals new rect. And then you can do r1 dot set h to 10 dot set width to 20, right? You think that's cool? Mm-hmm. I don't. I never used it as a pro programmer. Not one little bit. Textbook shows it though, so I wanted you to see it. I was surprised to even see the concept in the textbook. If I wanted to be able to set two things at once, I would make a double wide get setter, right, that took both height and width. Overloaded methods. Overloaded methods is when you have multiple methods with the same name. So suppose you had a class, whatever, and it needed to be able to process things. So process string, and it took some kind of string, blah, 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 it did something with it. And then you had another one called void process int, and it did something different if you passed it an int. And then you had a third one that if you passed in an array, an array of ints, and it did something with that. Well, that's all well and good. But you might consider doing this. Instead, you might overload those methods, which is providing multiple methods with the same name. They have to be of different types, but they can have the same name. So I'm just going to copy this whole shebang, paste it, and then do this. I'm just going to remove that specialty thing. We don't need to distinguish. Oh. All right. There. We don't need to distinguish whether it's a string I or IA. We don't need to have that distinguisher in the name anyways, because the Java compiler will go, oh, you got a string? Well, I know which method to send to. I'll use that one. If you pass it an int, it'll go, oh, I can use that one. What is the advantage of that? So that in your driver, right, you have some object named, it's of the whatever class. And then you're going to call process. You can do this, 1, 2, 3. And you can do what, dot process, and you can pass it an int. And if you feel like it, you could process an array. Like that. With the same name. Makes the code easier to read. Yeah, you had to do some work to do this, but that's probably better than having to do this, and do this, and do this. And if you don't agree that it's better, yeah, you can come to that opinion, and I won't argue with you. The advantage, perhaps, of doing it this way is that as you decide to make it support more data types, it still looks good. You, or whoever's working with you, all they need to remember is I'm going to call dot process. And then if they need it to handle, floats or arrays of Boolean or whatever, they say, hey, modify dot process so it'll take floats. And you do it. Rather than tell them, okay, I'm going to add a new method and you're going to have to use it by this name. Right. Kind of standardizes it. That's called method overloading. Providing multiple methods with the same name but different parameter lists. My classic example is to come up with methods that accept multiple numbers of parameters. So you're going to write an add method, and it takes 2 ints, and another one takes 3 ints, and another one takes 4 ints. And I'm not providing the whole code, right? You know, you get it. I'm not going to actually go in and code what it does. H, I, J, K, L. I hate L because it looks like a 1. So I'm going to switch to X. All right, and so this would just, why not? Won't take long. Return I plus J. This one would return I plus J plus K, and so on, right? You get it. And blah, 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 right? So, in your client code, in your driver code, if you want, you could do this, right? Say we had this as a utility class of some kind, class utils, or mathy stuff, or something like that. We're going to jump ahead as soon as I do this to talking about static. All right, so if I wanted to use these utility functions at this point in my driver code, I'd have to make a new util object. Util equals new util. And then I could, print add 1, 2 if I wanted to just add 2 numbers. And I could print add 1, 2, 3, like that. And then print add, 4, 5, 6, 7, whatever, right? But I can't because I don't know where add is stored, so I would have to do util.add, util.add, util.add. Now this is a class with no data, right? I have no member variables at all. If you have a class with no data, it is completely pointless to make an object of that class. If you could call these functions and not have to have a class, great, right? That's a wasted step. When we use a scanner, we have to create a new scanner because it's a data class. It's got data that manages, whatever it's scanning from. But if you need to do math functions like math.pow, you don't create a new math object. You just import the library. We'd like utils to be written like that. So I'm going to copy this and make another one called utils2 if you're taking notes. Utils2, and these are going to be declared as static. Good idea. I should have closed the door. Thank you. Or I could start shouting. Nah, I won't do that. Thank you. Okay, so now that I have these utils declared as static, that makes them class members. Class members are static members. You don't have to make an object to use them. So to use those guys, I don't have to create a new object. I just refer to it by its class name, right? So print, obviously we know that print's not a real, right? Utils2.add 1 and 2. And then print utils2.add 1, 2, and 3, and so on. Print utils.add 1, 2, 3, and 4. So in that homework that I called conversions, I said you could write it as static or not. If you felt like making the members static, go for it. If you felt like not doing that, Totally cool. Doesn't really matter. This only side effect is you have to create an object. Is it bad news that you have to create an object before you use your util class? No. It's just a decision you can make. There may be times when you want to come up with a static method for a class that does have data. The only side effect is that that static method will not be able to interact with that data. If for some reason I have a variable in here, I don't know, right? Since this guy's not static, these aren't going to be able to modify it. Static methods cannot modify non-static data. Or, if we could use the book's terminology, class methods cannot modify instance data. This is instance data because it's not marked as static. This data does not even exist until you do a new, right? Utils2 equals new utils2. This variable doesn't even exist. Doing static methods is kind of like just adding functions to a C++ program, right? It's not even object-oriented programming anymore. You're just adding functions to stuff. I'm not going to try to come up with a reason for why you would have static methods that access non-static members. I can think of some, but I'm not going to demonstrate them right now. So just know that static class members are static members, and then instance members are non-static members. Once you leave the word static off, it's an instance member. It's either an instance variable or it's an instance method. Now I need to modify that statement. You don't have to make an object to use class members. You do have to create an object to use static members. We're not going to get much time to talk about arrays today. I don't care. I think that even for people who took Java just last semester, that this is not all pure review, that you're not all going to sleep. And plus, half the class did not take Java with me, and I cannot guarantee what I taught, what you were taught. You had great teachers, but I can't guarantee what you were taught. And I like knowing what you were taught. So we're doing this review and renew, review plus more. I think that's what we're doing.
Question.
Yes?
You said you do have to create an object to use static members, but in your example...
Oh, that was supposed to be instance. Thank you.
Okay.
Thank you for catching that.
Okay.
All right.
Just contradicted what you said.
Here. Slap my wrist. Slap my wrist. There we go. All right. Thank you. That's clear, right? This is why we were able to use utils2, because these are static class members. We did not have to make an object of that type. In our original util class, they were non-static. They were instance members, so we had to have an instance in order to use them. We all good on that? Okay. Now here's a good point. If you have a constant in a class, if it's never going to change, you may as well make it static. Right? I don't know what constant this is going to be. How do you define constants in this language? With the word final. So max, files for whatever purpose. So final int max files is equal to 10. We cannot open more than 10 files at the same time. Whatever purpose, right? You should not have to create a utils object just to find out the number of max files. You got to just be able to query it. If files, is greater than, I don't want to have to create a utils2 object to check it. I just want to be able to say if files is greater than utils2.maxFiles. Right, that's all I want to be able to do. To get that to work, I would have to make this static. A very real example of that is the math class, which has pi and other mathematical constants built in. You would not want to have to make a new object just to check the value of pi, right? You just want to import math and then be ready to go. Actually, you don't even have to import math, do you? When we use math.pow, is it one of the default ones brought in? I forget. I think that's true. Well, if we had open Netscape today, we would have known that. We could test it right away. I don't foresee us opening Netscape this late in the game. For those of you who watched the video, I have not inordinately duplicated material from that lecture, have I? The fact that I see questions being asked makes me think that I have not. I try not to do that. If I ask you to watch a video, I don't want to just come up here and repeat it. I want to enhance it. And I know that talking about static is a bit of a repeat, but I also think that it was very useful. Alrighty.
There is a method for math.py, so I'm guessing you do have to import a library.
None of the math methods require an object. Every single object in the math class is declared as static. So you don't have to create a math. Now, if you spot one, I believe that to be a truism.
Well, I mean, it just says it's part of
Right.
the class. So,
Okay,
so you
right.
Can, like, import it.
So yeah, when you use, right, okay, thanks. We just confirmed that you don't have to do import math. Is that what you're
We do have to import math.
We do kind of import math.
Yeah.
Okay, okay. You have to import the math library, the math class, in order to use math.py, but you don't have to make a math object.
I asked you that it's in Python 2 days ago. You said no.
Yes, you have to import math.
I asked
Sorry
you-
about that.
I
In C,
said-
I thought you were talking about C++, I think, and if you said Java, then my brain glitched.
I just
A
wanted
lot
to
of,
be sure.
yeah, a lot of the math functions in Microsoft C's version of C++ are there, and they shouldn't be in the general library. They should be in the C math library that you have to import.
Yeah, but C++, I know you said you had to import the CMath one, but I
Right.
asked you, do you have to, I'm pretty sure you have to import the
Yeah.
library for math and Java, and you said no.
Well, I lied. Somebody needs to slap my hand again. All right. Ouch. All right. Sorry about that, Vincent.
If it does an automatic import, you don't got it.
Yeah.
I mean, he made me question my entire
Yes.
knowledge.
Your view of the universe.
Or maybe.
All righty. So, talking about arrays. We really don't have time to do a review on arrays. I need to make the array assignment have a later due date. On the other hand, you have hopefully watched the video over it. Comment I want to make about it is if I say something like write a method or write code that will calculate the minimum, maximum, sum, and average of an array, there are some incredibly easy ways of doing that. You can use the arrays class. The arrays class has methods for sorting the array. Once you sort the array, you're guaranteed that the minimum is the first element, and you're guaranteed that the maximum is the last element. Simon did it that way, I believe, and I didn't yell at you. I mean,
yeah.
you asked me for permission, and I didn't tell you to revise it. And that's the way a programmer would do it. I want you to have kind of tucked away in your brain how to do that otherwise. Just because processing lists and sequences of data is such a fundamental part of computer science. But on the other hand, why rewrite the wheel? And it was the same thing in Python, right? Python has a cute little sum function, which you can, and a min function and a max function. And then you can also learn how to do those things manually. Now, in those classes, I consider those classes not, that's, the 1100 level class, not the 1600 level class or the 2600 level class that this is, right? And so I usually don't make people, write too many, sum methods. But I do make them do it a little bit, right? You write a little method that'll open up the array, and iterate through it. So if you need to find skipping entirely how to declare an array, I guess I'll go ahead and do that. We're going to declare an array of ints. I'm going to call it nums, and I'm just going to type in some random numbers. Now Java does not mind if you put the square brackets at the end of the variable rather than at the end of the data type. However, that's C++ style, and you should avoid it. But they mean the same exact thing. So why Java decided to push it over there when C++ already had 20 years of long established, anyways. So we're going to create some numbers. Now we're going to find the highest value. Well, I made it the first one. That's stupid, right? Okay. So you would write a for loop or a while loop or something like that. I would need to create a variable that held the first value, right? I'm looking for the highest. And I'm going to set it equal to the first value. Then I need to iterate through it. I'm going to use a for each loop. For int value in nums, if that value is greater than the current highest that we know about, then that becomes the new highest. Like that. If you were going to find the lowest, you'd just change that sign. And is this going to crash if your array has no data? If you had done none is equal to that, which is possible. Yeah, this code will crash. It's one of the drawbacks of rewriting the wheel, right? Is that the people who have developed classes like the arrays class, it's been tested, over 20, 30 years. Okay, so, and then if you were going to sum this stuff up, I like storing my sums as doubles, even if I'm just calculating ints, so that later on when I calculate the average, I don't have to worry. Don't have to worry about what, doing integer division and it winding up, an int divided by an int is rounding down. You can easily get it to say that the average of something is 0 when it absolutely was not. Okay, so double sum, you have to initialize it to 0, that's your accumulator, and then it's the same code. For every value in the nums array, sum plus equals value. Then if you're going to calculate the average is equal to the sum divided by, now we could have been counting the items as we went. And technically I ought to make you count the items as we go. But let's just cheat and ask the array for its length. Like that. And that should also be a double. So that's like just about the entirety of the arrays assignment, if I recall correctly. New homework inspired by Simon is going to be to rewrite this using the arrays class.
Oops.
I blame you. I blame you. Okay, so how do you do that? We might not even have time to cover it. But you're going to sort the array first so that you can find the minimum and the maximum, because I do not believe that there's an arrays.min function. I could be wrong about that. Let's find out. Arrays.min. Java. Okay, yeah, you can do it, but you have to convert the array into a list with a call to collections, and okay, so there's not one. So what you would do is, in order to use this, you would have to import the arrays method, And then later on in your code, when you're ready to use it, I should just pull up Simon's code. It's already got it. Is that you could do arrays.sort.
I don't think I turned it in. So
Oh, you didn't? Okay. All right. You could do arrays.sort and then pass in that nums array. Now the array is sorted, small to big. Then you can get the small value out, right, real easily. Int small is equal to nums subscript 0. Again, that would blow up if the array was an empty array, but you ought to rule that out earlier in the code, right? If nums.length equals 0, then print a message saying, you fool. And then the last one is going to be the last element in the array. So int large is equal to nums, and the position of the last one is the length of the array minus 1. Remember, because zero-based indexing, if it's got 10 elements, we can go 0 to 9. So nums.length minus 1 gets us the position of the last element in the array. Remind me, there is a sum function for arrays. Oh, that doesn't look too happy. All right. To get the sum and the average, you have to do it the other way. So maybe this isn't a big enough news in order to make you do it a completely new assignment. But I would like it. Extra credit. If when you do the arrays assignment for the rainfalls, you go back and edit it to use the above way of getting the small and the large. I'll make a Dropbox to that effect.
Do you want us to make it a sort instead?
Yeah. In order to do this part, for the extra credit, you would just need to sort your array, and then you could get the smallest and the largest values out that way. You don't need to recalculate the sum or the average because there's no cute, easy way to do that using the arrays class. Now, this is a way that a lot of people would do it. Your general rule of thumb is that sorting is expensive in processing time, but so is searching the array. Sorting is more expensive than searching the array, so if you're only going to check an array once to find its smallest value or to find an element in it, search for an element in it, then you don't need to bother sorting it. But if you're going to be doing a lot of searches into the array, right, if you're going to use it a lot, random access, then it's far better to have it sorted. Because you can, get the smallest and the largest just that easily, rather than writing, having for loops go through it. And you can use binary searches. A binary search is incredibly far quicker. Like in order to, on average, if you have a 100 element array and you're searching for a specific value and you start at the beginning and you go until you find it, on average it's going to take 50 seeks into the array in order to find it. It's a linear search from beginning to end. A binary search will take at most 7 seeks in order to find it, due to the miracle of binary searches, but it has to be sorted to do that. So sorting the array, if you're going to be making a lot of access into it, is a really good thing. Databases keep their data sorted by creating indexes, right? Just for that entire reason. You would not want to have, a 100 million record database, and then in order to find somebody, have it open, the database and check every record in it. Instead, you'd want to just be able to do a search. There would already be an index, hopefully based on the field. Alrighty, guys. That's really not enough homework to give you. But let's go look at what I have coming up on you. an array on a video on parallel arrays, max values, and searching. I'd rather do that one by hand. So I'm not going to assign you that video. We're going to do that one by hand next time. So here's where my numbering scheme falls out of whack because we did not cover this topic. We went back and we covered other stuff. But no biggie. So create, this is going to be another homework assignment. Or how about just revise your conversions class to use the alternate method. If you made static functions, change them to non-static. If you made non-static functions, change them to static, and then re-upload it. So you're going to have your bonus assignment. You're going to have this one. And so the 2 short assignments is okay, I think. All right, and 3 people watched the video over parallel arrays, max values, and searches. I'm glad you did that, but unfortunately when I lecture I'm going to be repeating it. Hopefully I present it in new and good ways. So some of y'all are going to be getting, I don't know, I should give extra credit for the folks who watched ahead. And then the rest of y'all would wish that you had that extra credit. I will try not to make it too much of a rehash for those of y'all who did it. But I'm going to try to avoid making you watch the video on your own. So, is that okay with y'all? If I don't make you watch the video and you guys who did aren't going to feel too put out? How about you, Brian? You going to resent the fact that there's getting a slide by? All right. So, I think that's enough homework. No videos to watch for the next week. Sound good? Does anybody have any questions? Brian, was there something I promised to cover in email that I didn't? Because you were asking me some questions.
Yeah, I was asking about the videos that you made. There was a video that was about the agency.
Okay, I need to post one. Yeah, I made a video for the online Java class, which was an extra review of writing getters and setters and the fundamentals of class creation. I will post that tonight, okay?
And explanation about
I'm sorry, my hearing is so bad.
explanation of driver files and how they work with the, what do you call it, front and back end?
Yeah, I can give that explanation right now. Let me go ahead and make it. I guess we don't even have a Dropbox for this. You want a Dropbox that just upload a note saying you were here, or? Yeah, no Dropbox. Okay, so the idea of a driver class is that once you make your car class, sorry guys, or once you make your utils class, once you make any class, when you're ready to use it, then whatever has your main method in it is the driver. It's going to create new cars, it's going to create new rats, it's going to use your utils class. This is the client. It's not a client-server relationship, but this code here is the client for the car class or the utils class or whatever. I always recommend not sticking your main method inside one of your other classes, but keeping your drivers separate. If you feel like it, you can get it to work where your main method is actually inside the car class or the utils class or whatever. It's still going to be a static method, strongly recommend you don't do that. Always recommend that you create a separate class. And so whenever I give you a homework assignment and you do, new project or whatever, and it creates new project, it's got a main. If I tell you to write a sphere class or a rectangle class or whatever, don't call that one sphere. Lynn's done this because, it makes sense. I'm making a new homework. I'm going to call it sphere. You're going to want that to be a separate class. You're going to want a driver for it. So you're going to make a separate sphere class that embodies all the stuff from the UML or whatever that I wanted you to have. That makes sense? That a little bit better? We have a little bit more time before I run off to the next class. So we can hang out a little bit early. Otherwise, I'm letting y'all go.
So to use that file, you'd have to declare, you have to create an object, right?
Right, in order, once I have, what I technically should be doing is putting every class in its own file. Now, you don't have to. I could put a class right inside my main file, my main Java, or whatever you called it, as long as it's not declared as public. You can only have one public, but really, the car class should be in its own file called car.java. And then when we have main.java, it's got a class called main. Maybe I should have given it a different name. But inside here, then there's going to be a public static void main. And that's going to be your driver. Your driver is going to make use of that car. Car C1 is equal to new car. And then it can get down to business of, setting the make and the model or whatever it was supposed to do. Hope I answered your question that time. If not, keep at it. Don't let me get out of here with that. All righty. Any other questions? Because we did exit a little bit early.
So when we
Yes, ma'am.
redo the rainfall,
Yeah.
you wanted to have a separate class? Is
No. I was just talking, rainfall doesn't involve a driver and a client at all, does it?
that, no.
Unless I specified it. No. You don't have to revise it in that fashion.
Okay.
Right. You could. Yeah, you could make every project you do have your data in a separate class, but unless I ask for it, you don't gotta.
Okay.
Yeah. But I did say, didn't I, put every class in its own file and not to just reuse the one with main, and I see why you started thinking that I meant to, separate it into a separate class, but no, it didn't need to be. All righty. Hopefully that was just enough fun. I don't want to overload you with too much fun.
You don't have to import math to use math.py because math is apparently built into just the basic, but you do have to import a specific method from the math class if you want to use just pi. Instead of typing math.py, you can just type in pi.
Oh, so you're talking about the special one where you go in
Yeah, you can
Which
just
language?
type in pi for pi.
Which language?
Java. So I'm
You
not
can bring it
interpreting
in such a way that you can do that? You can get to math.py anyways?
Yeah.
Okay.
You can just use math.py whenever.
Okay.
You have to import a specific thing if you want to use pi.
Right, okay.
Yeah, I didn't remember adding the math class, but sometimes it adds it for you, so.
Yeah.
Yeah.
I was getting that answer
Works
now.
with it, I think, but I'm off tomorrow, so I'm
Okay.
starting copy tomorrow.
Okay, and you heard that the last video became not necessary to watch, so that I
Yeah.
hope you can catch up a little bit faster. Okay, cool.
Thank you.